All right, so good morning. I just got off the phone call, great phone call with someone that's coming in from New York, getting ready to come in and get started, which is fantastic. And in that conversation, we got on a topic that I realized is really helpful to probably talk about on a bigger scale. And it centers around the idea that not everyone in the world, believe it or not everyone in the world is obsessed with thinking about the brain and neurons and how to rehab them the way that I am. And that's totally okay. But I want to communicate what that means, because I think sometimes it's hard to be able to make the jump from, hey, I've got a concussion, I've got a brain injury, I got this thing going on. How does what you do translate into me feeling better? Which is a fantastic question. And I think the easiest way to explain that is to kind of dial it, like pull it all the way back and think about like what is at the basis of that. And for me, when I think of that, it's really a term that's called, or it's a concept in neurology that's called synaptogenesis. And it is the birth, like the genesis, the building of synapses that connect between neurons within the brain. Okay, so if that sounds sciencey, I get it. So the way that we can think about that, really simple. I have 3 kids right now, and they're 8, 6, 3. They're all at different stages of learning math, right? So I got an 8-year-old, he's in 3rd grade, super into it, learning, all the things. Addition, subtraction, multiplication, division, right? For some of you, those are like pain points. But he's learning those right now. And then I got a 6-year-old who's like super into like, counting as high as she can and working on like grouping things together, subtracting them apart, right? Using what they call manipulatives, right? So using different objects to like make groups, pull things apart, and start to do basic addition and subtraction. Excuse me. And then I got a 3-year-old who's just like super pumped that she can count to 13, right? And then what you realize is that when we try to teach kids how to do math, we don't just take them like to an accounting office and just like throw them in the corner of the boardroom and are like, yeah, just hang out here for a while. You'll pick up math as you go. Like you'll just get it. It'll be fine. We don't do it that way. We have a concept when we can apply it to math, but we can apply it to all the things we learn. All the things we learn come from structured learning, right? So you learn one thing first, and it's the baseline, right? So like I learn how to speak, and then I learn how to count, and then I learn how to write a number, and then I learn how that applies to different groups of things, and then on into calculus, right? So it's like one layer stacked on top of another, right? So it's like building blocks, Jenga blocks, right? You're stacking them up. And that builds us into these complex tasks, and that's how we run around as humans, is like this collection of integrated, complex tasks, skills, things that we can do. So if you take someone that has a concussion, we injure synapses, we injure axons, or we injure dendrites, we injure different components of neurons. And when we injure them, we disconnect them physically. And when we alter their function physically, we change the output of what they can do from a skill perspective, right? So it's kind of like, we've got that stack of blocks that creates a skill, and if we come in and like knock that block, like Jenga those things down and they fall and they scatter, it would be unreasonable that we would expect to just re-immerse someone back into their life and still be able to do that stack of skills even though they're not connected to each other anymore. So that's the way we think about it, is how do we then look at a problem for someone? We look at how a thing works, how your brain functions, how you can do a task, right? So it would be unreasonable for us to say, if you can't balance on one foot, it would be unreasonable to expect you to be able to go back and play hockey at a high level, right? Because balancing on one foot is one of the sub-skills of skating, which is a sub-skill of playing hockey, right? So we look at, how do we break down and look at, well, what is preventing them from being able to balance on that foot? And then how do we go back into that stack of skills, relearn it, restructure the learning so that we can readapt it into bigger and bigger and higher level skills again. Same thing if you think about someone going back to work. Like if they can't remember 5 letters in a row, or excuse me, 5 words in a row, what is the probability that they're going to be able to like function as a high-level employee again. It's very low, right? So their ability to generate working memory is failing. Well, that is like one of two functions that's involved in executive functioning, right? So we have to be able to think about, okay, how do we break that back down, and how do we do things or skills, exercises that target synaptogenesis within that skill set that we can build back into a broader skill set again that they would operate as a human being. So that's how we want to think about it. So just to recap that real quick, we walk around as a collection of functional capacities, skills. And if we disrupt the connections that allow us to achieve those skills, we have to walk it back and restructure building them again. So if someone has problems with the way their eyes move, right? They go to move them to one position, but they hit the wrong position. Are they going to be able to read? Not well, right? And if they can't read well because their eyes are in the wrong position, there's a probability that they're going to use more energy because their eyes have to move around a whole lot more than they would otherwise. The skill's not going to be as good, and there's a likelihood they're going to develop symptoms because as they are trying to compensate for that skill, they are pulling resources from other areas that will either induce fatigue, will use up more energy, may cause strain in different muscle groups, whatever the thing may be. So what we would do in that position is, okay, if when they go to move their eyes there, what would be the mechanism of how the brain would actually use a pathway to put the eyes in that position, and how do we make that pathway put the eyes back in that position correctly, reproducibly over time, and then can we extrapolate that so we can do it in all the positions, so now we can go back to reading, now we can go back to driving, and be able to do it without having to have all of these compensations that weigh on our ability to do our life. Okay, so that would be an example of how we would think about translating basic, simple skills into more complex activities. So, to rewind again, so think about that, just button it up. So we think about a person with concussion, a person with a brain injury, a person with a head injury. We have a change in the actual substrate of the neurons, of the connections within the brain. What's beautiful about that is that we have this concept of synaptogenesis. We have the ability to learn how to do new things, create new connections in order to do that. The caveat is that we can't just randomly expect our brain to be able to acquire high-level skills if the substrate, the foundational skills, have errors. So if there are errors in simple skills, they will translate into errors in more complex skills. So our job is to go back to the simple portions, rewire them, right? Create new synapses, learn how to do it well, and then translate that into more complex skills and tasks and procedures, okay? So I hope that helps answer questions around like how do we take neurorehab and convert that from concussion, neurorehab into regaining skill, getting back to life, doing the things that you used to do in the first place. So I hope that helps. It was a good conversation, and I hope sharing it works for you. Thanks again, and we'll see you next time. Appreciate it.